yesterday and the day before when we were talking about conditional statements and we were talking about taking the converse of those statements and we were talking about deciding whether the truth value of those statements was true or false, that was to build up to today's lesson where we're talking about biconditional. A biconditional is basically what it sounds like. It's two conditional statements smushed down into one. Very important, they are converses of each other and they are both true. So you'll notice that, if you recall, the symbolic notation for a conditional statement was P arrow Q. You'll notice that the symbolic notation for a biconditional statement is still an arrow, but notice that the arrow is going both ways. And that's, again, to really symbolize the fact that this statement goes both ways. So in your assignments, you'll notice, and I just completely messed this all up. In your assignment, you'll notice that there's the biggest chunk of your assignment consists of, here's a conditional statement, is its converse true, and then writing a biconditional statement based on that. Or, here's a biconditional statement, break it down into its two conditional statements. Okay, so in problem 1, very much like one of the examples in last night's homework, my conditional statement is, and you can't see it very clearly on the screen, but you have it in your notes. The conditional statement is, if the sum of the measures of two angles is 90, then the angles are complementary. And we've been talking for the last couple of days about how to take the converse of a statement. Remember, when you're taking the converse, you're just flipping it around. So the converse of the statement would be, if the angles are complementary, then the sum of the measures is 90 degrees. That is the converse of the statement. So in essence, I'm doing two things here. I'm introducing our new lesson, and I'm also going over one of the problems from last night's homework. So let's make sure that we are clear about it. First of all I did was switch the statement around, making it the converse. The next thing that was also asked of you in last night's homework was, is that converse true? So, is it? If the angles are complementary, then the sums of the measures is 90. Is that statement true? If the angles are complementary, then the sum of the measures of the two angles is 90. Is that true or false? Hurt me.
It's true.
It's true. Yes, wake up. Okay. Because it is true, let's make sure that we're clarifying what we've done so far. So far, we have written the converse of the statement. That's this sentence up here. We've identified that that converse is true, and because the converse is true, I can now take those two conditional statements and put them together into a biconditional statement. One thing that I want to emphasize, we've been talking about these if-then statements. Those are conditional statements. When you are making a biconditional statement, make sure that your sentence is not starting with if. A biconditional statement, because it goes both ways, we call it an if and only if statement, and that if and only if phrase goes in the middle of the sentence. So our true biconditional statement that we would write would be, the sum of the measures of two angles is 90, if and only if the angles are complementary. That would be our biconditional statement. And again, I know that making these sentences in these different ways is very new to us. I want to emphasize, again, a conditional statement is if-then, a biconditional is if and only if. You have a question?
Can biconditional be false?
Fantastic question. The answer is no. Because understand, in order to write Can a biconditional statement be false? That's kind of a tricky question. Theoretically, in the truest sense of the word, you can't write a biconditional unless the conditional and its converse are both true. Could they throw a sentence that has an if and only if in it and ask you if it is a true biconditional? I suppose they could, in which case you would be asking yourself, is the statement reversible? I'm not sure I've answered your question.
No. So basically, if we're writing a biconditional,
It better be true, yes.
But if they're asking us if it is, then it could be not, it could not be.
Yeah, that's kind of tricky. Okay. To emphasize the whole biconditional idea, the fact that it does go both ways, do we see that on the board I have the sum of the measures is 90 if and only if the angles are complementary. But I could have also put the angles are complementary if and only if the sum of the measures is 90. It goes both ways. Either answer would be correct. Okay, you'll notice on the board where I've indicated your assignment that once again this might be another one that you'll want to type. It's a lot of sentence writing. I know some of you are a lot more comfortable typing stuff like this than handwriting it. And we're still getting from this screen? In problem 2, they're asking us to do the exact opposite. In problem 2, I have a biconditional statement. In other words, I have something with if and only if in the middle of it, and I'm being asked to rewrite it as 2 conditional statements. Realize, they're going to be converses of each other. So for my first sentence, I could take this biconditional, 2 numbers are additive inverses if and only if their sum is 0. My first conditional statement could be, if 2 numbers are additive inverses, then their sum is 0. And then the other conditional statement would be, if their sum is 0, then the 2 numbers are additive inverses. It's just a matter of rewriting it in 2 different forms. And again, I know some of you are looking at this and kind of glaring at it. I thought I was in a math class and I didn't have to write a zillion sentences. It doesn't last for long, I'll give you that. And it does have a purpose. What we are trying to build up to is talking about what makes a good definition versus a definition that maybe we wouldn't want to use. Before we get there, however, let's take a moment within our groups and discuss your turns for problems 1 and 2, please. So within your groups, you are working through the your turns for problems 1 and 2. The whole reason why we talk about these biconditional statements and how they go both ways is so that we can talk about what it means for a definition to be a good definition. Like having your phone out would be a bad definition of student. Anyway, in problem 3, you'll see that they're talking about, is this definition reversible? And that's one of the important qualities of a good definition, is that it does, just like a biconditional statement, go both ways. So in problem 3, the statement is, an equilateral triangle is a triangle with 3 congruent sides. So what I'm asking you is, is that statement reversible? Yes or no? If I flip it around, is it still true? Does it still make sense? Yes or no? An equilateral triangle is a triangle with 3 congruent sides. If I flip that statement around, is it still a good statement? Yeah. Yes, it is. So it is reversible, and because it is, notice the next part of the instructions for problem 3, we're being asked to write it as a true biconditional. Can someone please give me that sentence as a biconditional statement? Again, something with an if and only if in the middle of it. What would that sentence sound like as an if and only if statement? How might I rewrite that sentence? An equilateral triangle is a triangle with 3 congruent sides, but I want an if and only if in the middle of it. Taylor.
A triangle is an equilateral triangle if and only if it has 3 congruent sides.
Beautifully put, yes. A triangle is equilateral if and only if. The IFF, ladies and gentlemen, is an abbreviation for if and only if. Feel free to use it. I do. So a triangle is equilateral if and only if it has 3 congruent sides. Finally, in problem 4, they're giving us a bunch of statements and asking us which one would be a good definition. Remember, in order for something to be a good definition, it has to be reversible. That's the really big ticket item that we're seeing in today's notes. Also, you want to make sure that the definition isn't vague. There are no words in it that are not really meaningful and significant. So rather than just kind of calling out what the correct answer is, let's go through all of the choices and identify if it is a bad definition, why it is a bad definition. So in choice A, is that a good definition? Yes or no? Is choice A good definition? Dogs are animals with 4 paws. Is that a good definition?
No.
Ooh, we're split.
No.
Remember, ask yourself first, can I reverse the statement?
Well, it's not saying dog.
If I reverse the statement, I'm saying an animal with 4 paws is a dog.
No, because
That's not true. Okay? So we would say that this is not a good definition because it's not reversible. How about choice B? Is that a good definition? Squares have 4 sides. Is that a good definition? No. Is it a bad definition for the same reason? In other words, is it not reversible? Benjamin, put the phone away.
It's not reversible.
It's not reversible. How about choice C? Is that a good definition? Tuesday is the day before Wednesday. Yes, it is.
No.
That is therefore.
Yes.
Yeah, but Wednesday is the day before Tuesday.
What?
So the day before Wednesday is
Tuesday is the day before Wednesday.
The day before Wednesday is Tuesday.
Yes.
That makes sense.
Ugh. I definitely get what you're saying.
Well, just because everyone else is like switched. What's the difference between that?
It's too opinionated for math.
You really bring up a good point that I can't say the day. No. Yeah, the day before Wednesday is Tuesday. Yes, sorry. It does make sense. It's not. Now understand. Some of you are thinking of it along the lines of, let me clarify where the confusion
Are
is.
you saying like the day before when? Oh, okay, yeah.
Right. Let me clarify where even I kind of lost it there for a second. The confusion that some of us are having with the reversibility of that statement is that some of you are reversing it and saying Wednesday is the day before Tuesday, and that's not the case. I would reverse this statement to say the day before Wednesday is Tuesday, and that is in fact true. That is the correct answer to the question. Yes, ma'am.
So you have to look at it both ways to see which one, if either one, which in that works.
I'm sorry.
Like-
Repeat your question.
Because is the day before, couldn't it go both? So it could be true and false.
Well, it is. That one is the correct answer, and let me give you a tip that might help understand how you're reversing the statement that might be helpful. Remember when I taught my lesson on writing a conditional statement when the statement wasn't in if-then form. If you recall, the point that I stressed to you was that the subject of the sentence was the hypothesis and everything else was the conclusion. If I'm reading this sentence, Tuesday is the day before Wednesday, do you see that the subject of the sentence is Tuesday? And then the rest of the sentence, you see, would be the conclusion. And when I flip it around, it is true. Okay. Finally, D, we already know is not going to be the correct answer. We know it's not going to be a good definition, but why not?
Because there's no definition of a small number.
Right, small is just too vague a word to put into a definition. I have a daily quiz for you.